Hello class, welcome to lesson 3.5, using studies wisely. So what we want to do is identify when it is appropriate to use information from a sample to make what we call an inference about a population and generalize it to the population, and when it's appropriate to make an inference about cause and effect. So we also want to evaluate a statistical study and to see if it's been carried out in an ethical manner. So we want to look at the ethics, quickly discuss the ethics of studies as well. All right, so first thing we want to look at is inferences about a population and how that looks like. So when you do a study, you tend to want to draw conclusions, and these conclusions about a population are known as inferences, right? So you want to infer what the population might look like by taking a look at a sample. So let's look at an example. So for instance, the U.S. Census Bureau, we know carries out what we refer to as a current population survey, right? So and it does it about, in this case, it does it, pretty regularly, I would say. And they look at 60,000 U.S. households with the goal of inferring or estimating the percent of unemployed Americans, right? So this is let's just suppose we're looking at this goal, right? So if we want to determine this, so in this sample survey, the individuals needed to be chosen at random, right? So the idea is that when we do a sample, we want to choose them. We want to choose our individuals for the study at random, and the reason being that we want to eliminate bias, right? And by doing so, that allows us to make good inferences about the population, because if I choose a random sample, that means that sample is going to be more representative of the population as a whole. So what we want to do is avoid bias and then produce a reliable estimate. So essentially, randomization allows us to make inferences about populations. So if I want to make an inference about a population and generalize what I find from a sample to the population as a whole, then I must include randomization in my study. So what about inferences about cause and effect? So how do we apply cause and effect to some variables? So let's take a look at an example of that. So suppose some scientists perform an experiment that showed that sleep deprivation causes a decrease in performance. So they assigned 21 volunteer subjects. Notice that these are not randomly picked subjects; these are volunteers, and they are assigned to a sleep deprivation group and an unrestricted sleep group. So we know that they were placed into random groups, right? So because it says that they were randomly assigned. So here, the idea is that they were randomly assigned. However, the subjects were volunteers. So there's two different things going on here. There's this idea of random assignment, but the individuals are not randomized. Like the sample is not randomized. So in this study, we have random assignment. Also, we know that because they have so because they were placed into random groups, right? One group was sleep deprivation and one group was unrestricted sleep, so they can sleep as much as they want, right? There's no restrictions on that. Then that means that since we put them into random groups, that allows us for us to determine cause and effect, right? So because we can clearly see that if people were randomized into groups of whether they sleep or not sleep, we can see that if there's a change in performance, right? Even if we did not randomly pick 21 people because they were volunteers, we could still see that there's patterns in both groups, right? Because we did random assignment. However, because these are volunteers and we didn't take a random sample from the population itself, that means that we can't necessarily apply this conclusion to generalize it to everyone else. So if that makes sense. So yes, there you could tell for that group of people that there might be an effect between the sleep deprivation and then unrestricted sleep, but you won't be able to apply it to everyone else. And so this is important because you don't want to, if you're on a study, you find a really important finding with your group, well, that might work with your group, right? There might be definitely a pattern going on, but you won't be able to apply it to people as a whole, to the population as a whole. So it's very important that you not only include random assignment, but you include randomness in the sample that you chose. Okay, so this really is just showing a couple of things, right? So to summarize, we have random selection of individuals. So we want to randomize the sample that we use, right? And that allows for inference about the population. So you can take your results and then kind of infer about the population as a whole. And then random assignment allows you to determine cause and effect, right? So there might be a cause and effect relationship between, for example, the sleep deprivation and then their performance, right? So, but you won't be able to apply it to the population as a whole if you don't have random selection of individuals. Okay, so here's sort of like a chart, a matrix of sorts. So if the individuals are randomly assigned to groups, right? So if we say yes to this, then we can make inferences. If they're randomly assigned to groups, then we can make inferences about cause and effect, right? Notice that. If they are not randomly assigned to groups, then we cannot say cause and effect, right? Because they might be volunteers. They might volunteer for a particular type of group, and then you'll have the same type of people volunteering for the same type of group, and then that's going to eliminate, the whole purpose of doing the experiment, right? So in identifying what the true root cause is. Now, on the other hand, if the individuals were randomly selected, then you can infer stuff about the population. So let me circle that. So if they were randomly selected, then you can infer about the population. So in that case, these will be both a yes, right? So there's like 4 different combinations of these guys. All right, so let's look at the first example. So the headline of a recent article declared there was a study, teens getting less sleep, social media could be a reason. So using random samples of teens from 1991 and 2012, the study found that teens are getting less sleep than they did 20 years earlier. For example, just over half of 15-year-olds reported at least 7 hours of sleep in 1991. But only 43% of 15-year-olds reported this much sleep in 2012. Okay, so can the results of this study be generalized to all teens in the years 1991 and 2012? So they said that they used random samples, right? So they used random samples of teens from 1991 and between 1991 from 1991 and to 2012. So can they generalize this to all teens? And the answer is yes, technically they can, right? Because they can actually do this because they used random samples, right? So the idea is that if they randomize the samples of teens, and then get this data when they analyze it, then they can generalize it. So we're going to say because of randomization. So we're going to say yes, because the study used random samples. Of teens from both groups. Okay, so they did get random samples from both groups, so we could make an inference to the population, right? Now, let's take a look at the second part. So based on the study, and is it reasonable to say that the use of social media is the cause of the reduction in the sleep? So we know that the teens are getting less sleep, right? According to this, we can generalize it. Hey, teens are getting less sleep based on the random samples that they took. So that's a problem, right? We don't want teens getting less sleep. But can we identify the root cause as social media is what we want to find out. And so the only way we can do this is to actually do random assignment, right? So we have to put randomly assign teens to a group where they use social media, and then a control group where they don't, right? So they avoid using social media. And then we look at their sleep pattern and see if that changes. So because the study didn't mention anything about this, right? We're going to say no. So just because they're getting less sleep doesn't mean that social media is a cause. So no, we cannot say that. The teens have to be randomly assigned. So this is random assignment. Have to be randomly assigned to either so let me put this to groups that either use social media or a group that does not, right? Or a group that avoids it, or a group that doesn't use social media. And that would sort of be like our control group, right? The group that might not use social media, just to determine if it's the social media that's the issue, right? So that's the only variable that we want. So that means the other two groups, everything else has to be the same when we make these groups, right? So all other variables have to be the same because we want to also eliminate confounding, right? Because there could potentially be other variables involved. It might not just be social media. It might be, some other stuff like video games or just a lack of exercise and in general, right? Maybe they're not exercising as much, and then therefore they're getting you know they're getting less sleep because they might not be using up their energy in the day. There's a lot of variables involved. So when you make these groups, you have to make sure that everything else is constant. So for example, they have to have the same amount of exercise, for example, per day, if you think exercise might be a cause. So they have to have the same rough activity levels. um, Other variables have to be kind of like the same so that you can kind of eliminate this confounding issue. So it's something to keep in mind. All right, so let's take a look at another example. So here it says many students insist that they study better when they listen to music. So a teacher doubts this claim and suspects that listening to music hurts academic performance. Here are 4 possible study designs to address this question at your school. In each case, the response variable will be the student's GPA at the end of the semester. So, so they want to address this question, of listening to music and their performance, right? Their academic performance. So, first scenario, get all the students in the statistics class to participate in the study. So ask them whether or not they will study with music and divide them into 2 groups based on their answer to this question. So let's take a look at that one first. And so let's focus on this one, and then we'll get to the other ones. So what conclusion can we draw from each study? So we want to determine the conclusion that we can draw. And assuming that the mean GPA for students who listen to music while studying is significantly lower. So it says assuming that the mean GPA for students who listen to music is lower than the mean of GPA students who didn't, right? So we kind of want to assume that in order to draw our conclusion. Okay, so all right, so let's take a look at that first scenario. Okay, so I wanted to include that question beneath it just so that we kind of remember what we're trying to answer. So again, we're trying to answer what conclusion can we draw, assuming that the mean GPA for students who listen to music while studying is significantly lower. So the reason why we're assuming this is we're just assuming that when we actually took the survey of the students in the class, that when we collected the results, the mean GPA for those students in that class was actually lower when they listened to music. So we're just assuming that that took place, right? So we know the GPA for those students, and we know which students listen to music and which did not, because we asked them, right? And that's part of and question number one. We asked them whether or not. So because we're asking them whether or not they study, and we're conveniently using the students in our statistics class, right? That's a sort of like a it's sort of like a convenience thing, right? That means the sample is not random, right? So let's go ahead and just include a couple of bullet points here. So we know that there was no randomization done. So I've just as a bullet point. So no randomization means that we cannot infer what's happening. We cannot infer the results that we have here to the population, right? So the results can't be generalized to the population. So can't be used. I'm going to say can't be used for the population, or can't be applied to the population. Let's do that. They can't be applied to the population, essentially. Like the population as a whole, right? So meaning all student bodies, right? So like the entire student body or whatever, because we're only using students in our statistics class. So we can't just generalize these results, right? Because we didn't include randomization. And we also don't have random assignments. So there's no random assignment. So because there's no random assignment, well, then that means that we can't infer cause and effect. So we can't determine whether the music was the cause of of maybe a lower GPA, right? So we can't infer cause and effect. Okay, so that's basically the idea. So now let's go ahead and generalize a response for this. What conclusion can we draw? So it says, assuming that the mean GPA of students who listen to music is lower. So we can conclude that that's true, right? So we can conclude the default assumption here, the default assumption that the mean GPA for students who listen to music is while studying. I'm going to assume that we're talking about while they're studying, is significantly lower than those who didn't. Okay, than those who didn't listen to music. All right, so we can conclude that. However, because there's no randomization, we can't apply this to the population, right? We can only use this for this group of students, basically. Okay, so we're going to go ahead and say with no randomization, with no randomized individuals, I guess you could say. We can only apply this result to this group of students, to this class of students. I'm going to say to this statistics class. That might be easier. Just kind of reword this. Okay, so we can only apply the results to this statistics class in particular because we didn't randomize. So we can't be applying it to the population. We can't make generalizations about this. So now we also don't have random assignments. So that means we can't infer cause and effect. So we're going to say with no random assignment, we can't determine whether music is the cause for this decline, right? So whether music is the cause for the decline in the GPA. Okay, so the default assumption was that the mean GPA is significantly lower for students who listen to music than those who didn't. So that's the default. We assumed that we collected that data from our class. And so that's what happens. But we can only apply these results to our class, right? That's what we found. We can only apply it to our class. And there might be reasons for that, right? Why they have lower GPA when they listen to music. Maybe there's other variables involved. Maybe the students are just not motivated without some kind of stimulus, right? There's a lot of things, right? So with no random assignment, we can't determine the root cause of this. That music is the cause, rather, because we need to include groups where we can control for those variables. Okay, so let's take a look at the second one, the second case. We select a random sample of students. So now we have randomization, right? So that's good. From your school, so this is the school as a whole, to participate in a study. Ask them whether or not they study with music on, and divide them into two groups based on their answer to this question. So there's no random assignment again, right? You're asking them, do you study with music on? And if they do, you put them in that group. And so not only is there no random assignment, but people know which group they're in, right? So something to keep in mind. So what conclusion can we draw? So again, remember the default assumption. So again, we can make this conclusion, right? That the whole GPA versus the music versus GPA. So we can conclude that students who listen to music while studying have lower GPAs. Now, because we included this idea of random sampling, we can actually apply this to the general student body as a whole. So have lower GPAs and due to randomization, I'm going to say due to randomized individuals, we can apply this to the population, or we can infer this to the population. However, we can't determine that music is the cause. We can't determine any cause and effect here. There's no causal effect here. That is the cause. And the reason why we can't determine that music is the cause here is because we didn't include random assignments. So the students were asked whether or not they study with music on, and then we put them in that group. So they not only do they recognize the group that they're in, they are put in based on whether they do the action or not. So you're not actually applying a treatment to them. You're just observing, what their preference is, and then putting them in that group. Due to lack of random assignment here. All right, so that was essentially the second case in our matrix, that table that we had. So we got two more cases. So the third case is get all the students in the class, in the statistics class, to participate in a study. So we're doing a specific class, right? So here, so all the students in the statistics class. So that means that there's no randomization. So we're going to say that here, which means we can't generalize this to the student body as a whole, right? Randomly assign half of the students to listen to music while studying for the entire semester, and then have the remaining half abstain from listening to music while studying. So now we have this idea of random assignment, right? So we have a yes to that. So what conclusion can we draw? So we can conclude that music is so if this is true, right? Then we can conclude that music would be the cause due to the fact that we did a random assignment. However, we won't be able to apply these results to the population as a whole. So we'll go ahead and write that. So we can conclude So we can conclude that listening to music, right? So the actual process where the students that listen to music actually caused this decrease, right? So listening to music while studying causes, and I'm going to underline that, that's important here, causes the students to have lower GPAs. And I'm going to put this in parentheses. This is because of random assignment. So that was really the reason for that conclusion. And now here the idea is but. So the only thing about this conclusion is it can only be applied to the student, the students in this class. But this is only for the students in the class. And this is because of lack of randomization. So, I mean, it's good that we were able to conclude cause and effect, but we won't be able to apply it to other students, as a whole. And in the last case in the matrix here, we include randomization, so check on that, and we include random assignments. This is the best case scenario. Yes to both. So when we say yes to both randomization and random assignment, then not only can we make conclusions about cause and effect, we can actually apply this to the population as a whole. So this is the best case scenario. We can conclude that listening to music while studying, in this case, causes the students to have lower. So here, I'm going to put underline causes here because that's the really important part here. And that bit is from, so that part right there is from the random assignment. So to causes them to have lower GPAs on average. So this is, of course, typically. So we'll go ahead and put that on, on average, this is assumed for all the students. Now we can apply this to the population, right? So for all the students in the school. So now we can apply this to the population, right? So remember that we had the population was the student body, the entire set of students in the school. And then we just have this portion, which was the statistics class, right? Now, when we included randomization, then that means we included kids from not only the stats class, but from different classes, right? And doing this allowed for an increase in diversity. And because of that, then we had a sample that was more representative of the population as a whole, and therefore we can make inferences about the population as a whole. in addition, we randomize the groups that the students were in, and so that will help us determine whether there's a cause and effect relationship. So there's a couple of elements to this. Okay, so let's take a look at the ethics of data collection. So there are certain situations in which performing experiments would actually be considered unethical, and this is sort of a limitation in the study. So, and if we want to study certain topics, like for example, the premise, the idea that smoking now we know causes lung cancer was not evident earlier because we could not make experiments on students, right? So, or on just people, and we can't just randomly assign people into groups of smoking versus non-smoking due to ethical issues, right? Um, an example of this would be texting while driving. Will that increase the accident risk? Well, we can only glean from the data from observational studies. It's not like we can do an experiment on that for human subjects. So that's an ethics situation there. So, in order for the evidence to be strong for these types of situations where experiments can't be done ethically, it has to meet strict criteria in order to show cause and effect. So, even though these are observational studies that need to be performed, we have to consider that there needs to be a strong sense of evidence by looking at multiple cases. So, you can determine cause and effect, but it's gonna have to meet strict criteria if there's an ethics situation here. So let's take a look at the basic principles of data ethics. The first thing you want to consider is that the planned studies must, because due to ethical situations, the planned studies must be reviewed in advance by an institutional review board. So this board is specifically used for the safety of human subjects. So the other thing that you want to consider is when you're putting human subjects to a treatment in an experiment, you have to give them informed consent prior to the data collection. So that means informing them of any of the risks, any of the entirety of the procedure that's going to be done, right? So, and then you have to obtain their consent in written form. And then finally, for one thing that you want to consider is that the data must be kept confidential. So let's assume that they consent to the data collection and they consent to the experiment. Then they must have their data be kept confidential. So according to HIPAA, the HIPAA Act, so Health Insurance Portability and Accountability Act, right? So there's HIPAA regulations that you want to make sure that you adhere to, and then the only information that can be applied, that can be actually used and made publicly available, is like stuff like statistical summaries, like what was the average, for example, if we were talking about sleep studies, what was the average amount of time of sleep, right? So or this, what's the standard deviation? So we can apply statistical summaries and we can make that publicly available, but any other specific information must be kept confidential when we're looking at individual data. So these are some principles of data ethics. So let's take a look at an example. Will people try to stop someone from driving drunk here? So this is just the scenario here. A television news program hired an actor to play a drunk driver and used a hidden camera to record the behavior of individuals who encountered the driver. Was the study carried out ethically? And explain. So we're assuming that this is the only thing that happened, right? We had, someone playing, this actor, and then we wanted to see like the behavior of people and determine if they'll actually stop someone, right? By using a hidden camera. Now, because this camera is hidden, that means they don't know that the camera is there, and therefore there's this consent issue, right? And so that is violating one of the principles that we mentioned earlier, the idea of informed consent when you're looking at this experiment. So we want to keep that in mind. Also, because the participants were filmed for the program, that means it's publicly available, and you want to consider issues such as their individual data. In this case, you're looking at their behavior. The results need to be confidential, which in this case they're not. So what we're going to say is no. There are some things to consider here. So no, due to confidentiality, it's due to lack of confidentiality. As this is a publicly viewed video, right? Publicly viewed video, and lack of informed consent. And this is because we had hidden camera. Okay, so even though you can look at studies, I mean, this is a study that could be done. It's when you look at a study, you want to consider the ethics involved in it. So they might be able to get some results from this, but you want to also consider that you don't want to violate someone's ethics. And in addition, you definitely don't want to put people at risk when you're doing the study. And so that's why sometimes, even though you want to do an observational study or a particular experiment, you have to consider the experimental design. All right, that's going to do it for the video, guys. I hope you found this useful and informative. And as usual, I will see you in the next one.